Hello folks, we are back with our next video, that is on the problem number, let me check, the problem number 23. It says that prove that the curves x equal to y squared and xy equal to k cuts at right angles if 8k squared equal to 1. So they have given two curves and they are asking us to uh, prove that these two curves cut at right angles. Now curves cutting at right angle, it's very difficult to find out. So the curves are well identified by its tangents. So it is enough for us to show that the tangents cut at right angle. So once the tangents cut at right angle, it means that the curves cut at right angle. So the entire problem is reduced to finding that the tangents to both these curves are cutting at right angles. So for the curve 1, we will find the tangent. For the curve 2, we will find the tangent. We will find the dy by dx. So that means it's a slope of the tangent 1, and then you find dy by dx for the second curve, you get the slope of the tangent 2. We'll just check if m1 into m2 is -1. If it is, then they are cutting at right angles. So it's only that much. So that's our work. So as I told you, it's very difficult to check that the curve is cutting at right angles. So we just modify it and go to the tangents. It's well identified by the tangent, and then for the tangent we will check that the product is -1. Meanwhile, they also give us that 8k squared is 1. The k is occurring here. So there is a relation 8k squared equal to 1, which means k squared is 1 by 8 and so on. So that also you could use for your calculation so as to get the whatever they ask us. So let's start working. For x equal to y squared, dy by dx is our intention. So let's find derivative with respect to x. Derivative of x with respect to x is 1, and derivative of y squared with respect to x is 2y dy by dx, or rather it is dy by dx equal to 1 by 2y. Since it's for the curve 1, for our convenience, let m1, let's call it as 1 by 2y. And now we consider the next curve, xy equal to k. Here also we will find dy by dx by taking the derivative with respect to x on both sides. X, it's a product, so x into dy by dx, y as it is, derivative of x is 1, k is a constant, derivative is 0. So dy by dx, y goes on the other side, minus y. X is there here, so that gets, it goes to the other side, and see how it goes. It becomes dy by dx will become minus y by x, and here also for our convenience, let's call it as m2. M2 is minus y by x. Now we all knew from the introduction that I gave you in the beginning that we have to get somehow m1 into m2 is -1. At least we'll find out what is m1, m2 and check whether we're getting it as -1 or not. So let's check. Therefore, because we want the product, so let's do m1 into m2. M1 for us is 1 by 2y and m2 for us is minus y by x. Okay, y is cancelling. That itself is a convenience. And now we have got it reduced to -1 by 2x. That's it. So we are not able to simplify it further. It is staying at -1 by 2x. But it's okay, at least something. So now somehow you should get a value of x. Then only we will be, it is meeting at a point. The curves, we don't know how the curves are. There is this curve here whose tangent is like this, and there is another tangent. So they probably are perpendicular, probably that curve is like this. So they, like that. So there is a point of meeting. So that is why we will try to it is definitely intersecting at a point. That is clear. The curves are intersecting at that point, and at that point the tangents are perpendicular. That's what we are trying to show. So with that in mind, we'll try to solve both these. So we'll say, consider the intersection between the curves. The curves. Intersection means always like you can substitute one in the other like that. So x equal to y squared and xy equal to k. Suppose if we square this, so this will come x squared y squared equal to k squared. Now why I am doing that? Because k squared value we know. so that it will help us to get the value. So x squared, y squared, k squared, and y squared is x, we know. So let's simplify this. So therefore, from here, you can have x squared and y squared as x, k squared as 1 by 8. 8k squared is 1, means k squared is 1 by 8. So what will come? X cube is 1 by 8. So if x cube is 1 by 8, taking cube roots on both sides, x will become cube root of 1 by 8, which is 1 by 2. So you get the value of x as 1 by 2. That will help us to make the substitution here from 1 and 2. Yeah, that's because we know it is intersecting at the point. What is happening to m1, m2? It is becoming minus 1 by, no more 2x, it's 1 by 2. We got the value as 1 by 2. So you can have the 2 cancelling. Answer is minus 1. So what will happen? Therefore, the tangents are perpendicular to each other. Yeah, because slopes have become, product has become minus 1. So let's conclude properly. Therefore, the given curves cut at right angles. Therefore, the given curves cut at that's all about it. That how, so it's not possible for us to just attack the curve and do, it's impossible. So we are switching over to the tangent, and from there we are seeing it. That's all. So that's about it, and with the next problem we meet in the next video.